October 24, 1944, 0647 hours. Philippine Sea. The hydraulic fluid traces a thin crimson line across the salt-stained fuselage of Lieutenant Commander David Mack Campbell's F6F Hellcat as it approaches the USS Essex, her flight deck pitching 7 degrees in the morning swell. The aircraft's landing gear hangs at an unnatural angle, the starboard strut collapsed inward like a broken limb. Inside the cockpit, Mick Campbell can taste copper, whether from the hydraulic mist seeping through the ventilation system or from biting his own cheek during the last hard break. He cannot tell. His fuel gauge reads 18 gallons, enough for perhaps 4 more minutes of flight, perhaps 3.
The arresting cables stretched across Essex's deck look impossibly thin from this altitude.
Gossamer threads meant to catch 6 tons of wounded steel hurtling forward at 90 knots. Behind him, the sky over Leyte Gulf burns orange, where the morning sun ignites the smoke from burning Japanese ships. He has been airborne for 7 hours. He has fired every round of ammunition his Hellcat carried, and now, with his wheels damaged and his hydraulics failing, he must attempt what Navy pilots in the ready rooms whisper about in tones reserved for ghost stories, a carrier landing with compromised gear. This was not how it was supposed to be. Not for the pilots who flew the Grumman F6F Hellcat, not for the men who had been promised the most forgiving, most survivable fighter aircraft ever to launch from an American carrier deck. The Hellcat had been designed specifically to erase the nightmares that plagued every naval aviator since the war's beginning. The nightmares of twisted metal, of fire blooming across flight decks, of young men trapped in cockpits as their aircraft tumbled into the Pacific. Grumman had built the Hellcat as an answer to those nightmares, as a promise that American engineering could protect American boys even when everything went wrong. The landing gear was redundant, over-engineered, designed to absorb punishment that would shatter the undercarriage of any other fighter. The hydraulic systems ran in parallel, each capable of compensating if the other failed. The fuselage was reinforced with frames that could withstand impacts that would tear apart a Wildcat or a Corsair. Grumman had even nicknamed their plant on Long Island the Iron Works, a boast that every aircraft rolling off their assembly line was built not just to fly, but to survive. Yet here, in the reality of combat over the Philippine Sea, survival depended not merely on engineering specifications written in Long Island offices, but on the terrible arithmetic of battle damage accumulated over 7 hours of continuous air combat. McCampbell's Hellcat had absorbed hits from at least 3 Japanese aircraft, a Zero that raked his starboard side during the initial engagement over the Japanese fleet, a Judy dive bomber whose rear gunner stitched rounds across his wing root as he pursued it down through 4,000 feet, and finally, a wounded Oscar that exploded so close to his aircraft that shrapnel punctured his hydraulic lines and jammed his landing gear mechanism. Each hit individually was survivable, precisely as Grumman had promised. But together, compounded by 7 hours of combat maneuvering that stressed every system beyond its design parameters, they transformed the Hellcat from an instrument of American technological supremacy into a barely controllable projectile aimed at Essex's flight deck. The Japanese pilots who had engaged McCampbell that morning over Leyte Gulf understood American abundance as a theoretical concept, an abstract threat discussed in pre-mission briefings conducted in crowded ready rooms aboard carriers that burned fuel oil so heavy it left black residue on every surface. They knew the Americans possessed more aircraft, more carriers, more replacement pilots. The intelligence summaries distributed to Japanese naval aviators in October 1944 contained precise figures. The Americans were producing over 9,000 aircraft per month, their training programs graduating more pilots than Japan had sent into combat during the entire first year of the war. But theoretical abundance and experienced abundance were different species of knowledge entirely. The Japanese pilots who survived encounters with Hellcats that autumn described not merely superior numbers, but something more psychologically devastating. The absolute certainty radiating from American formation flying that every aircraft would be replaced. Every pilot who died would be succeeded by another equally well-trained. That American industry rendered each individual combat merely one transaction in an endless ledger that would inevitably balance in America's favor. This certainty manifested in how Hellcat pilots fought. They did not conserve ammunition for the final approach. They did not break off engagements to preserve aircraft. They flew with what Japanese reports termed reckless expenditure, burning fuel and ammunition at rates that would have grounded Japanese squadrons for weeks, knowing that the support vessels steaming behind the carriers carried reserves sufficient for months of such expenditure. When Mack Campbell had launched that morning, His Hellcat carried 200 rounds per gun and its 6 Browning machine guns, 1,200 rounds total. By the time he turned back toward Essex, he had fired every single round, not in a desperate last gambit, but in methodical, disciplined gunnery that treated ammunition as infinitely renewable. The Japanese pilots who faced such tactics understood they were not merely fighting individual aircraft, but the entire industrial capacity of a nation that could afford to send pilots into battle with orders to fire until empty, then return home for more. The Hellcat itself embodied this philosophy of abundance through forgiveness. Where the Japanese Zero achieved performance through minimalism, stripped of armor, self-sealing fuel tanks, redundant systems, the Hellcat accumulated weight with the confidence of an economy that could afford to waste horsepower on survival features. The aircraft weighed over 12,000 pounds fully loaded, nearly twice the weight of a Zero. Yet this weight purchased survivability that Japanese pilots could only regard with desperate envy. The Hellcat's engine, a massive Pratt & Whitney R2800 radial producing 2,000 horsepower, could absorb damage that would instantly kill the lighter Japanese power plants. The fuel tanks, each encased in self-sealing rubber compounds that swelled when punctured, denied the Japanese their primary method of killing American fighters. The incendiary trace that sent so many Zeros down as blazing torches required only a single hit on an unprotected fuel tank. The Hellcat's pilot sat behind armor plate and armored glass, added weight that Japanese designers rejected as incompatible with their performance requirements, yet which allowed American pilots to survive hits that would have killed them in less forgiving aircraft. This forgiveness extended even to the ritual that Mac Campbell now faced, the carrier landing, that moment of controlled violence when every training flight ends and every combat mission concludes. The Hellcat's wide-track landing gear, its docile handling characteristics near stalling speed, its rugged structure that could absorb landing impacts that would collapse the gear of other aircraft. All of these were designed to forgive pilot error, combat damage, and the inherent violence of slamming a 6-ton aircraft onto a moving deck at 70 knots relative velocity. Navy training officers called the Hellcat easy, a description that carried no condescension but profound relief. Unlike the Vought F4U Corsair, which killed dozens of novice pilots during training with its vicious stall characteristics and obscured forward visibility during approach, the Hellcat allowed average pilots to achieve safe landings and enabled exceptional pilots to survive landings that should have killed them. Yet Mac Campbell's Hellcat was no longer the forgiving machine that Grumman had built. The starboard landing gear, damaged when shrapnel from that exploding Oscar severed the hydraulic line controlling its extension mechanism, hung partially deployed but unable to lock. The backup mechanical extension system had engaged, but the gear remained cocked at an angle, its wheel tilted inward. If that gear collapsed during landing, the Hellcat would cartwheel across Essex's flight deck at 70 knots, transforming from aircraft into tumbling debris that would sweep flight deck crew into the ocean and potentially ignite the other aircraft spotted aft. Mac Campbell knew this arithmetic with perfect clarity. Every naval aviator knew it. The flight deck safety films shown during training at Pensacola had documented such catastrophes with clinical precision, each frame reinforcing the lesson that a bad carrier, landing, threatened not merely the pilot but dozens of sailors and potentially the entire ship. The voice of Essex's landing signal officer crackled through Mick Campbell's radio headset, professional and unhurried despite the situation. "You're high, Rebel. Power off. Come left." The LSO could see what Mac Campbell could feel. The Hellcat was approaching too fast, too high, the damaged hydraulic system affecting his control response. Mac Campbell eased the throttle back, feeling the big radial engine spool down the propeller's note dropping from a scream to a growl. The Hellcat settled, its nose rising slightly as airspeed bled off. Through his windscreen, the flight deck crew scattered to the edges of the landing area, their yellow jerseys bright against gray steel. The crash trucks, already manned, tracked his approach with their foam cannons elevated. Everyone aboard Essex understood what was about to happen. Everyone had seen it before. The question was not whether it would be bad, but merely how bad. This was the moment that separated American carrier aviation from Japanese. Not the quality of individual aircraft or the skill of individual pilots, but the systematic infrastructure of survival that surrounded every carrier landing. The flight deck crew wore uniforms color-coded by function, a system that allowed instant identification and coordination during emergencies. The crash trucks carried foam suppressant in quantities sufficient to blanket an entire aircraft in seconds, smothering fires before they could spread. The medical teams waited below the flight deck with supplies and training equivalent to a major civilian hospital, prepared to treat burns, trauma, and shock. The ship's damage control parties stood ready to contain fires, seal ruptured fuel lines, and jettison burning aircraft before they could threaten the vessel. All of this infrastructure, this layered redundancy of survival systems, existed because American carrier doctrine assumed that things would go wrong, that aircraft would crash, that pilots would make errors, and that survival depended not on preventing every accident, but on systematically limiting the consequences of each. The Japanese possessed no such infrastructure. Their carriers operated with minimal crash equipment, minimal medical facilities, minimal damage control. This was not oversight but deliberate policy born from economic necessity. Every ton devoted to safety equipment was a ton unavailable for offensive weapons, for ammunition, for fuel. Japanese carriers went to war carrying the minimum necessary for operation and nothing for contingency. When Japanese pilots crashed during landing, the standard response was to push the wreckage overboard and spot the next aircraft. If fires broke out, flight deck crews fought them with hand extinguishers and seawater. If pilots were badly injured, they received whatever medical care could be improvised from the ship's small, sick bay. The results of this minimalist philosophy became apparent in the casualty statistics. Japanese carriers lost to fire initiated by relatively minor crashes, Japanese pilots dying from injuries that American medical teams would have treated routinely, Japanese operational readiness declining because every accident extracted disproportionate cost. Mac Campbell's Hellcat crossed Essex's fantail at 85 knots, 10 knots faster than optimal, the damaged hydraulics preventing him from extending his flaps to their full landing configuration. The deck rushed up, gray and stained with rubber from 1,000 arrested landings. The LSO dropped his paddles in the cut signal, indicating Mac Campbell should chop throttle and commit to landing. Mac Campbell pulled the throttle to idle, feeling the Hellcat drop, the nose rising as airspeed bled away. For one crystalline instant, the aircraft hung suspended, neither flying nor falling, balanced on the knife edge between controlled flight and aerodynamic stall. Then gravity reasserted itself with savage insistence. The Hellcat's main gear struck Essex's deck with a sound like a building collapsing, metal shrieking against metal as the arrestor hook scraped across steel before catching the number 3 wire. The tail hook grabbed, the wire stretched, and in the space of a single heartbeat, the Hellcat decelerated from 85 knots to 0 with force that slammed Mac Campbell against his harness, hard enough to crack 2 ribs. The damaged starboard gear, stressed beyond its compromised capacity by the violent deceleration, collapsed inward with a grinding scream of tortured metal. The Hellcat dropped onto its right wing, the wingtip striking the deck and generating a shower of sparks as aluminum scraped across steel. The aircraft pivoted around the still-engaged arrestor hook, rotating clockwise as it ground forward on its belly in collapsed gear, pushed by residual momentum. Flight deck crew threw themselves flat as the Hellcat spun across the landing area, its propeller chewing into the deck and disintegrating into fragments that whined through the air like shrapnel. The fuselage, reinforced with those Grumman structural frames that had been the subject of so much engineering pride, absorbed the grinding impact of sliding across steel decking, the armor plate beneath the cockpit striking sparks but preventing the pilot compartment from being crushed. The left gear, still intact, dug into the deck and helped arrest the rotation, finally bringing the Hellcat to rest 40 feet from its initial impact point, canted at a 30-degree angle with its right wing collapsed and its propeller reduced to a twisted stump. For 3 seconds, nothing moved except the foam spraying from the crash trucks as they converged on the wreck, smothering the engine compartment before leaked fuel could ignite. Then, Mac Campbell's canopy slid back, and the pilot emerged from the cockpit under his own power, waving off the medical corpsman as he climbed down from the bent wing. He had landed with damaged gear, absorbed a carrier arrestor that pulled 8 Gs, survived the aircraft's collapse and subsequent spin across the deck, and emerged with 2 cracked ribs and a story he would tell with modest precision for the next 40 years. The flight deck crew, exhausted, terrified, and now flooded with relieved adrenaline, cheered as Mac Campbell stepped onto the deck. This scene, repeated in variations across American carriers throughout the Pacific War, encapsulated what American engineering promised and Japanese experience dreaded. The Americans had built not merely superior aircraft, but an entire system predicated on the assumption that combat would damage aircraft, that pilots would make errors, that equipment would fail, and that survival depended on layers of redundancy protecting human life at every stage. The Hellcat's robust structure, its redundant systems, its forgiving flight characteristics, these were not individual features. but expressions of an industrial philosophy that could afford to add weight for safety, to over-engineer components for survivability, to sacrifice some measure of performance for substantial increases in pilot survival rates. The statistics validated this philosophy with brutal clarity. The F6F Hellcat accumulated a kill ratio of 19-1 against Japanese aircraft, the highest of any American fighter in the Pacific. Yet more significant than kills was survival. Hellcat pilots survived crashes, wheels-up landings, ditchings, and combat damage at rates unmatched by any other fighter aircraft of the war. The Hellcat's safety record during training was so superior to the Corsairs that the Navy initially restricted Corsairs to land-based operations while Hellcats dominated carrier decks. When a Hellcat crashed during carrier landing, the pilot survived 87% of the time. When Japanese aircraft crashed during carrier operations, pilot survival was less than 40%. These survival rates compounded over time into strategic advantage that transcended individual combat effectiveness. An American pilot who survived a carrier crash returned to flight operations within days or weeks. A Japanese pilot killed in a training accident or operational mishap represented not merely one death, but the loss of hundreds of hours of training investment that Japan's limited resources could not replace. As the war progressed, this differential accumulated. Experienced American pilots flew combat tours, rotated back to training commands to impart their knowledge to new pilots, then returned for second and third tours. Meanwhile, Japanese pilot experience declined steadily as irreplaceable veterans died and minimally trained replacements went into combat, with 50 hours flight time against American pilots who had 500. The Hellcat's forgiving nature enabled this system of accumulated experience. Pilots survived their early mistakes, the errors in judgment, and execution that killed novice aviators in less forgiving aircraft. They survived combat damage that would have destroyed lighter, less robust fighters. They survived carrier landings that tested the absolute limits of airframe strength. And because they survived, they learned. The knowledge they gained fighting Zeros over Guadalcanal informed tactics taught to new pilots preparing for combat over the Marianas. The experience of surviving a wheels-up landing aboard Enterprise became lessons incorporated into training at Pensacola. American carrier aviation developed institutional memory because American aircraft design prioritized pilot survival highly enough to pay the weight penalty, to sacrifice some performance, to add redundancy that statistical analysis suggested would be needed less than 10% of the time. Japanese aircraft designers, constrained by limited resources and driven by military doctrine emphasizing offensive capability over defensive survival, made different choices. The Zero remained competitive throughout the war, its lightweight and excellent maneuverability allowing skilled pilots to match American fighters in individual combat. But every Zero shot down, every Zero that crashed during carrier landing, every Zero lost to operational accident killed not just an aircraft but likely its pilot. And dead pilots imparted no lessons to their replacements. The institutional knowledge of Japanese naval aviation died in burning cockpits over the Pacific. Each death-erasing experience that could not be replaced because the training pipeline could not produce pilots fast enough, and the aircraft themselves offered no forgiveness for error. Lieutenant Commander David McCampbell stood on Essex's flight deck that October morning, watching sailors secure the wreckage of his Hellcat, and felt gratitude that transcended simple relief at surviving. He was grateful for Grumman's engineers, who had added those extra structural frames that kept the fuselage from collapsing during the crash. He was grateful for the redundant hydraulic systems that, despite failing, had still allowed him partial control during approach. He was grateful for the landing gear design that, even damaged, had absorbed enough impact to prevent immediate catastrophic failure. He was grateful for the flight deck crew whose training and equipment turned a potentially fatal crash into an incident that required nothing more than pushing a wrecked aircraft over the side. And he was grateful for an industrial system that would replace his destroyed Hellcat before the week ended, that treated 6 tons of wrecked aircraft not as irreplaceable loss, but as acceptable cost of combat operations. This gratitude, shared by thousands of American pilots who survived crashes, combat damage, and operational accidents that should have killed them, generated loyalty that no amount of propaganda could manufacture. American pilots trusted their aircraft because their aircraft had earned that trust through demonstrated performance in the worst circumstances. They flew aggressively because they believed their aircraft would protect them when aggression went wrong. They took calculated risks because calculation suggested that even if the risk materialized, survival remained probable. This confidence manifested in combat effectiveness that Japanese pilots flying aircraft that offered no such assurance of survival could not match. The American pilot who knew his Hellcat would probably protect him, even if he made a mistake, fought differently than the Japanese pilot who understood that any error, any damage, any malfunction would likely prove fatal. The symbolic weight of that crashed Hellcat resting on Essex's deck before being pushed over the side to clear space for continuing operations exceeded its physical 6 tons by orders of magnitude. It represented American industrial capacity that could afford to lose aircraft at rates that would have grounded Japanese air operations entirely. It represented engineering philosophy that prioritized pilot survival even at cost to performance metrics. It represented training systems that could systematically produce pilots capable of surviving their mistakes because their aircraft forgave those mistakes long enough for learning to occur. It represented logistical networks that delivered replacement aircraft, spare parts, and repair equipment to carriers operating thousands of miles from American ports. And represented strategic vision that understood war as contest not merely of individual battles, but of sustainable systems, that the side which could maintain pilot quality and morale across years of combat would ultimately prevail regardless of tactical victories or defeats. The Japanese understood this by late 1944, though understanding brought no solution. Intelligence reports compiled by Japanese naval staff in the aftermath of the Battle of Leyte Gulf noted with clinical despair the American ability to sustain operations despite losing dozens of aircraft, to conduct multiple strikes daily, while Japanese carriers struggled to launch single missions, to replace combat losses so quickly that American strength seemed to increase rather than diminish after major engagements. These reports identified American carrier aircraft, particularly the Hellcat, as primary contributors to this disparity, noting that American pilots flew with confidence bordering on recklessness while Japanese pilots approached each mission with awareness that survival was improbable. The reports recommended crash programs to improve Japanese aircraft survivability, to build redundancy into designs to prioritize pilot protection. But by late 1944, Japan lacked the industrial capacity, the raw materials, and the time to implement such recommendations. The philosophy that had produced the zero, extreme performance through minimalism, was locked in place not by choice but by necessity. On November 4, 1944, Lieutenant Commander David Mack Campbell climbed into a new F6F Hellcat, Bureau number 70,143, delivered to Essex by a logistics vessel that had departed California 3 weeks earlier. The aircraft was mechanically identical to the one he had crashed 11 days prior, rolled off Grumman's Long Island assembly line, where workers built Hellcats at a rate of over 600 per month. McCampbell conducted his pre-flight inspection with the same methodical attention he applied to every aircraft, checking the landing gear locks, testing the hydraulic response, verifying that every redundant system functioned as designed. The flight deck crew spotted his aircraft on the catapult, hooked the launching bridle, and within 20 minutes of climbing into the cockpit, McCampbell was airborne again, leading his squadron toward Japanese positions in the Philippines. That cycle, crash, replacement, return to combat, exemplified the system that American carrier aviation had become by the war's final year. Individual pilots, individual aircraft, individual engagements mattered less than the aggregate performance of a system designed to survive losses, learn from mistakes, and maintain operational tempo despite casualties that would have paralyzed less robust forces. The Hellcat was the perfect aircraft for such a system. Not the most glamorous, not the fastest, not the most maneuverable, but the most forgiving, the most survivable, the most suitable for fighting a war of industrial attrition where victory would go to whichever side could sustain combat operations longest. Japanese pilots who encountered Hellcats in the war's final months reported not merely superior aircraft, but psychological erosion that came from facing enemies who seemed unkillable. They would score hits, see American aircraft stream smoke or lose altitude, then watch those same aircraft limp back to their carriers, land safely, and return to combat days later. They would shoot down Hellcats only to face equally skilled pilots in identical aircraft the next day, as if their victories accomplished nothing, as if American supply was literally infinite. This psychological warfare, unintentional but devastating, emerged directly from American design philosophy that treated aircraft as protective equipment for pilots rather than expendable weapons. The Hellcat communicated through its very existence that American industry valued pilot life highly enough to surround it with tons of armor, redundant systems, and forgiving flight characteristics. Japanese aircraft communicated the opposite. that pilot life was valued less than performance, that survival was secondary to offensive capability, that death in combat was assumed rather than avoided. The truth about American power, demonstrated through every hard landing, every survived crash, every pilot who walked away from wreckage that should have killed him, was that American warfare combined overwhelming industrial capacity with systematic commitment to preserving human life. These were not contradictory impulses, but complementary strategies. The same industrial capacity that produced aircraft in quantities Japan could not match also produced them with survival features that sustained pilot quality across years of combat. The same engineering culture that created redundant hydraulic systems and reinforced fuselages also created training systems, logistics networks, and damage control procedures that protected human capital as carefully as financial capital. American power was not merely quantitative but qualitative, not merely larger but smarter, not merely producing more but producing better systems for converting industrial capacity into sustained combat effectiveness. When Lieutenant Commander David McCampbell returned to the United States in January 1945, he had shot down 34 Japanese aircraft, making him the Navy's top ace. Yet the number that mattered more to the thousands of naval aviators who followed him into combat was different. Zero. Zero fatalities in his squadron attributable to aircraft failure. Zero pilots killed by carrier landing accidents. Zero deaths from systems malfunctions that proper design might have prevented. McCampbell's survival, his squadron's survival, the survival of thousands of Hellcat pilots who flew combat tours and returned home, validated every engineering decision that added weight for safety, every design choice that sacrificed performance for forgiveness, every dollar spent building aircraft that protected their pilots even when everything went wrong. The Hellcat's hard landings, its crashed hulks pushed over carrier decks into the Pacific, its damaged airframes limping back to friendly bases. These were not failures, but proof that the system worked, that American engineering had achieved its primary objective of bringing pilots home alive. In the vast arithmetic of industrial warfare, where victory belonged to whichever nation could sustain combat operations longest, the F6F Hellcat's greatest accomplishment was not its kill ratio, but its survival rate. It kept American pilots alive through the learning curve, through combat damage, through operational accidents, through all the 1,000 ways that carrier aviation could kill young men. And by keeping them alive, it allowed American carrier aviation to accumulate the institutional experience, the tactical knowledge, the strategic confidence that won the Pacific War. The Hellcat's legacy was written not in the aircraft it destroyed, but in the pilots it saved, not in its performance specifications, but in its forgiveness, not in the enemies it killed, but in the Americans it brought home.